Welcome to tutorial on subspace of a vector space. Recall the definition of a subset. A set W is called subspace of a set V if W is contained in V. Example is, if V is equal to R, the set of real number, then W is equal to set of natural number N is a subset of a V because W is contained in V. Definition of a subspace. Let W be a non-empty subset of a vector space V. W is called a subspace of V if W is a vector space under the same operation of addition and scalar multiplication as in V. Statement of a theorem. State necessary and sufficient condition for a non-empty subset W of a vector space V to be a subspace of V, or a non-empty subset W of a vector space V is a subspace of V if and only if the following conditions are satisfied. Condition number 1. If U and V belongs to W, then U plus V belongs to W. Means addition of U plus V should be in W. Condition number 2. If U belongs to W and alpha is a real number, then alpha into U belongs to W. If these two conditions are satisfied, then we say that W is a subspace of V. You see one example. Show that W is equal to set of all n tuples x1, x2 and so on, xn belongs to Rn such that x1 equal to 0. Means W is a set of all those elements whose first coordinate is equal to 0. It is a subspace of real vector space Rn. Solution. Let U is equal to 0, x2 and so on xn. Here the first element of U is equal to 0, first coordinate of U is equal to 0. Therefore, this element belongs to W. Similarly, V is equal to 0, y2, and so on yn. Here also the first coordinate is equal to 0, therefore this element belongs to W. And alpha belongs to R, means alpha is a real number. Then we'll check the condition number 1. U plus V is equal to 0, x2, and so on xn plus 0, y2, and so on yn is equal to first coordinate is added to first coordinate, therefore it is equal to 0, second coordinate is added to second coordinate x2 plus y2, nth coordinate is added to nth coordinate xn plus yn belongs to W, because here you can see the first coordinate of this element is also equal to 0, therefore this element also belongs to W. Means U plus V, addition of U plus V belongs to W. Condition number 2. Alpha into U is equal to alpha into 0, x2 and so on xn is equal to 0, alpha x2 and so on alpha xn. This is also belongs to W because the first coordinate of this element is again 0, therefore this element belongs to W. Hence W is a subspace of Rn because both the conditions are satisfied here, therefore W is a subspace of Rn. We'll see one more example. In V is equal to R3, let W is equal to set of all x, y, z belongs to R3 such that x plus y is equal to z. Means first coordinate plus second coordinate is equal to third coordinate. Show that W is a subspace of vector space V. Let U is equal to x1, x2, x3 and V is equal to y1, y2, y3 are in W, and alpha belongs to R, means alpha is a real number. U is equal to x1, x2, x3 belongs to W, means by the definition of set W, first coordinate of this element and the second coordinate of this element is equal to x3. Similarly, V is equal to y1, y2, y3 belongs to W. This implies y1 plus y2 is equal to y3. Now we'll check condition number 1. U plus V is equal to x1 comma x2 comma x3 plus y1 comma y2 comma y3 is equal to first coordinate is added to first coordinate, therefore x1 plus x2 comma second coordinate is added to second coordinate x2 plus y2. Similarly, third coordinate is added to third coordinate x3 plus y3. Now we'll check whether this element belongs to W or not. So we will have to check whether the addition of first two coordinate is equal to third coordinate or not. Now as x1 plus y1 plus x2 plus y2 is equal to, this can be written as x1 plus x2 plus y1 plus y2 is equal to, since x1 plus x2 is equal to x3 and y1 plus y2 is equal to y3, therefore it is equal to x3 plus y3. Therefore, because this condition is satisfied for this element, therefore u plus v belongs to W, means first condition is satisfied. Similarly, we'll check the second condition, alpha into u. Alpha into x1 comma x2 comma x3 is equal to alpha x1 comma alpha x2 comma alpha x3. Now here we will again check whether this element belongs to W or not. So we'll take addition of first two coordinate of this element, alpha x1 plus alpha x2 is equal to alpha x1 plus x2, and x1 plus x2 is equal to x3. Therefore, it is equal to alpha into x3. Therefore, alpha dot u belongs to W. Hence, W is a subspace of V. We'll take one more example. Let W is equal to set of all x, y, z belongs to R3 such that x equal to 0 or y equal to 0. Is W is a subspace of vector space R3? Explain. Solution. Let u is equal to 0, 1, 1 and v is equal to 1, 0, 1 in W. Here in u, first coordinate is equal to 0 and for v, the second coordinate is equal to 0 because the element of W are such that either first coordinate is equal to 0 or second coordinate is equal to 0. So these two elements belongs to W. But we can see if we add these two elements and check the condition number 1, u plus v is equal to first coordinate is added to first coordinate which is equal to 1. Second coordinate is added to second coordinate which is equal to 1. Third coordinate is added to third coordinate which is equal to 2. So the u plus v is equal to 1, 1, 2. So here we can see the elements of W are such that either first coordinate is equal to 0 or second coordinate is equal to 0. But here we can see first coordinate is not equal to 0 and second coordinate is also not equal to 0. So this element does not belongs to W. Therefore, W is not a subspace of R3. Thank you.